Simon and to Lee and the others for inviting us here to present this work today. I think it is important as a means of sharing ideas and between our two projects and looking to ways in which we might be able to link the two in some way perhaps. Also to say that, rather as Mike was saying, this is also very close to a presentation that was given at EMS. It's only a couple of weeks since then, so haven't been many further developments. So apologies to anybody who was in Lisbon and heard us present something very similar there. But I think it's largely a different audience and therefore will be of interest, hopefully. I'm going to give a brief introduction to the TAAALS project and the context in which our TIAALS software fits. And then Frédéric is going to give a demonstration of that software, and hopefully I won't speak for so long that we don't have plenty of time for the demo, which I think is perhaps the most interesting part for you. There's also a third member of our team, as you can see there, Peter Manning from Durham University, who isn't able to be with us today. And this again is an AHRC funded project. So TIAALS, Tools for Interactive Oral Analysis, is part of this TAAALS project, which is about technology and creativity in electroacoustic music. The AHRC funding is for 30 months. We're currently I think it's about 9 months into the project, so we've got a couple of years to go, nearly. And it is a study of the relationship between technological innovation, the way in which new technology has advanced in recent years, and the way that has been used in terms of musical creativity in producing works of electroacoustic music. And we have a number of research questions behind our project, but just to summarise, there is the main one, which is how has technology changed creative opportunities as we see them in the repertoire? In fact, has it? It's, I suppose, a basic question. And the way we're approaching this as part of the TAAALS project is to take 8 case studies. These are specific works by particular composers, and to study them in depth. And for each of these case studies, we're undertaking a contextual study, the background to the work in all kinds of ways, and Peter Manning is primarily responsible for that side of it. And then the musical analysis of the work, and also a technical analysis of the work. How was technology used to create this music? Because we're going to investigate that relationship between technology and creativity. Obviously we need to know both the musical outcomes, but also the technical means that were used. The outcomes we intend at the end of the project are going to include a book and freely available interactive software relating to each of the pieces. And the approach that we're taking builds, at least in part, on some of the earlier work I've done in what I've called interactive oral analysis. For those that don't know, let me just explain a little bit about interactive oral analysis. It's very much about experiencing the music as sound and interacting with the music orally. Learning by playing through software simulations with the techniques that the composer used. In a tonal piece, if someone is studying a piece of Bach or Beethoven, most people will be familiar with the basic tonal ways of working, and they'll be aware of the choices that face the composer, the way in which they might have deviated from the norms. That isn't often the case with people looking at electroacoustic music, and so our way of trying to resolve that is by giving people the opportunity to work with the technology, the techniques that were used by the composer, to recreate some examples from the work, to modify the way in which that was done, and to try out alternatives as a way of realising the significance of what the composer chose to do. My earlier work resulted in 3 analyses, 2 of which are available at the moment, and the third one should be available very shortly. You can see there Jonathan Hardy's Morceau's Playing of Viva Spogo, which was in Mary Simone's book. There's a chapter there, and the software is actually a current version for the existing operating systems is on our university website, and you'll see a URL for that later. The Dennis Morley analysis I did of wind chimes was part of one of the GRM polychrome portrait books from GRM, and the software is on their website. And shortly coming out through EarCam should be an analysis of Pierre Boulet's En Termes d'Œuvre. So I've chosen 3 pieces there over a period of time to represent somewhat different approaches to working with electroacoustic music. If you want to know more about this approach and more references and so on, an article came out recently in the Music Analysis Journal, and if you look at that, you'll find more information there. So TIAALS, Tools for Interactive Oil Analysis. And what we're trying to do as part of the larger TACM project is to create a generic set of tools for applying interactive oil principles to any composition. Previously, I'd designed software for each work as I came to it. The idea in this case is that we have software that can be transferred from one piece to another. So the idea is to facilitate the application of these techniques. It incorporates some of the ideas that I had in the earlier analyses, but it also incorporates some significant new features. And our initial reason for developing it is for our own use, so that as we come to study our 8 case studies, we will be able to use these software tools to aid us in our work. But we are also going to make this openly available so that other people can use it. It's work in progress, and it won't be fully completed until the end of the whole project in another couple of years' time. But we're going to present the current version of the interactive sonogram and the chart maker. They're not fully finished yet, although we're going to release a version publicly, we hope, in mid-August, and get feedback from people to help us refine what we're doing. There will be other features added which aren't there at the moment, and these will probably include tools to help with the analysis of the pitch element and also to do with spatialization. There are certain features of interactive oil analysis which have to be specific for a particular work, in particular where we make the emulation of the techniques that a composer has used. Obviously, they have to be geared to the particular techniques for that piece. Here's an example from the Jonathan Harvey analysis, the analysis that did of Mortuus Plango, and in that case I was creating a simulation of the way in which he created glissandi, not simply for their sound, but also as part of the structure of the work. And there are various boxes there that people can adjust and create their own processes similar to the one that Jonathan used, or they can put in the exact data that he used and get an identical result, I think I would even say, apart from very minor things to do with perhaps reverberation and so on being added. And in fact, the software allows you then to compare the original to what you've created. So we're going to demonstrate in a minute the interactive sonogram. And some of you may be surprised to hear me talking about a sonogram because I've been quite critical of them in the past. I think it was here at De Montfort at EMS in 2007, was it? And more recently in my music analysis article, I've been critical of perhaps overuse of sonograms in certain ways, and Simon was perhaps also, I think, hinting at that earlier. I think their limitations are usually when they're used purely graphically. If they are attached to sound and you can hear what the representation means, then I think they often do become much more useful. So our interactive sonogram allows readers to explore the sonogram as sound, to select particular regions and play them, to hear specific frequency ranges, and to scrub through the sonogram with a band-limited cursor, if you wish it to be band-limited, to pick out certain aspects of the sound and to hear what they're like. Sometimes we're asked, why didn't we use some of the existing software for sonograms? There are quite a range of programs now that exist. Well, we didn't just reinvent the wheel for the sake of it. We had specific things we wanted to do that we couldn't have done with the existing software. So one thing is that we wanted to be able to incorporate what we were doing in the interactive sonogram with our other software for interactive oil analysis, and all of this is written in Max MSP, so we wanted to work in Max MSP. Secondly, we wanted to be able to adapt the source code to our needs. We didn't want a closed program that we couldn't get inside. And thirdly, and I think this is very important, we wanted to be able to actually manipulate the FFT data. This isn't simply a graphic representation of a sonogram. Behind the screen there, the pixels, is the actual FFT data. And when you're filtering out certain frequency regions, what you're doing is manipulating the FFT data that is there in order to filter the sound or change the speed of the sound or whatever you're doing. And also, we found that the existing software, although in many cases very good in all kinds of ways, didn't have all the features that we wanted. One particular example, as you'll see in a minute, is we wanted to be able to make a link to what we call the chart maker. So just picking up on that chart maker, oral charts formed an important aspect of my earlier interactive oral analyses. charts are often important in analyses that people make. They're a way of showing structural relationships within a work. And some of the types of charts that I've used previously, as you can see there, include paradigmatic charts, taxonomies, genealogical trees, thematic charts, harmonic charts, and so on. Now, if you were doing this with a tonal piece, you would probably just do it on paper in a book, and you might use extracts from the score in order to show what the content of these charts was. You can't do that if a piece isn't notated, and so we think it's very important that these charts are oral charts. And what that means is that the buttons, the chart, it contains buttons that allow you to play the sound. So this is an example from the wind chimes analysis. This one's a taxonomy, and down the right-hand side there, at the end of each part of the taxonomy, there is a button, and when you click on it, you hear an example of that element of the taxonomy taken from wind chimes. That's a relatively simple example. A more sophisticated one here, also from the wind chimes analysis, is a paradigmatic chart, an oral paradigmatic chart, and you've got there, in fact, the whole work, this scrolls, so you can go through the whole work. We've only got the opening, I think, there. And again, each of these is a button that you can click on, and you can play the sound at that point. And in fact, it relates to the taxonomy, because down the left-hand side, you've in fact got the different categories of sound, the taxonomy, forming the basis for the paradigmatic chart. It's also perhaps worth noting that this is where I first used filtering, and so there's an option here. I think it's if you alt-click on one of these buttons, you actually get to hear just the frequency range that highlights that particular sound that I'm referring to at that point in the chart, and that's something that's been taken up in a much more sophisticated way in our TIAALS software. So the idea of the interactive sonogram linking with the chart maker is to make the process of making these charts much easier. Previously I had to do them rather laboriously by hand, but with this approach we have now, you can start with your sonogram, you can select regions on the sonogram that represent particular sounds, you can play them, you can test them out, and so on. You can then take those regions and you can put them onto a palette, and from that palette you can then place them onto the chart, and you can then make your chart in any way that you want for whatever particular aspect of the piece you are trying to show. You can also create playlists of the regions to play them in particular orders, and you can export the chart and data from it. This summarises that process. These are screenshots. You'll see the actual software in a minute. So here on the left, you've got the interactive sonogram with various shapes drawn on it to pick out those particular aspects of the piece. And then those same shapes, those same regions in the sound are then placed in the middle onto the palette, and then they can be categorized and grouped and linked in various ways if appropriate. And from there they can then be placed on the right-hand side onto the chart, and as I think Frédéric will demonstrate later, it's quite sophisticated in the way you can design these charts and make connections. And that, I think, follows through a typical approach to analysis of segmentation, leading to classification of the materials that have been identified in the segmentation, and then leading to the making of structural relationships between those different elements. Just a brief word on future developments. As I've said before, it will continue to be expanded and developed and refined for the remaining 2 years of our TACM project. We want to respond to user feedback, and if anybody's interested in using the software, I'll show you the URL in a minute where it should be available from mid-August. We certainly feel we want to go a bit further with the user interface and make, we've got quite a lot of options, and we perhaps want to make it a bit easier to navigate through those different options. We've got various features we want to add and others that we may discover as we use these tools with our case studies and discover that new pieces throw up new issues. It's perhaps also worth saying that in the interactive oral analyses and also in the new work that we're going to be doing, not everything will be based on software. It will be a text accompanying software. The importance of the software, of course, is it allows things to be an oral experience and an interactive experience. And following on what Mike was saying about there not being one analysis. When we present our analyses, I think very much we feel we're not presenting a finished task which is there, fixed in stone. We want to encourage our readers to actually explore the piece, following the guidelines we've given, and then perhaps make their own judgments and decisions which may be different from ours. So I say the initial public release is intended to be next month. We've got just a few things to iron out before we do that, but we think we're nearly there. If you want to know more about the TACM project, and if you want to download the software when it becomes available, the first URL there is the one to go to. If you want to find out about the previous interactive oral analyses, if you want to check where you can find those analyses and other text written about them, then there is another URL to follow through. And there should be links between those two, hopefully. And so for the rest of the time, we're now going to take an example. We've taken a well-known piece, part of De Natura Sonorum by Parmigiani and Plene Delier, and we're going to use that as a demonstration of the current state of the TIAALS software. And so at that point, I'll hand over to Frédéric to demonstrate that.
Okay, hi everybody. Just quit this PowerPoint and go to TIAALS. So I demonstrated according to the three main moments or windows that Michael mentioned, which are first the Sologram, second the palette, and then the chart maker. So here you have in this Sologram window a view of the overall. Oops, sorry. Thank you. I just have to mirror my view. Yeah. Okay. So this is view of the whole length of the piece, which is about 4 minutes, a bit more. So the sonogram is fully interactive. As you can see it, I can just, as in any software, can click anywhere and play it. Let's check the sound is fine. But for analytical purposes, obviously it's important to be able to navigate in any possible region. So you have several modes for acting on the sonogram, which are navigation, scrubbing, I'll be back on it just in a couple of moments, drawing and selection. So if I'm in the navigation mode, I can zoom in any portion of the sonogram. So for this demo, I'll just go to the beginning of the piece. And you can either zoom or navigate through the sonogram. So in order to explore the sonic content of whichever piece you are studying, we implemented the scrub mode, which just enables the user to just click anywhere on the sonogram and clear its contents on one given moment in time. Can you hear it correctly?
This is on the right hand on the micro mixer.
On the micro mixer?
That's you right?
I'm not sure which channel it is.
Yeah, this is the master. You've not got any volume. Yeah.
It's coming out of the speakers.
No, this is it. Hang on, volume down. Yeah.
Very loud.
Okay, so here we have the whole spectrum of the piece, from 0 to 20 kHz. But if you want to just hear a specific frequency region of the sonogram, you have an option to reduce the scrub range, which is this button here. So I'll reduce it to 500 Hz, for instance. Then can you see properly the scrub cursor? And then I just be able to hear what actually is under this specific region. So this is a very useful tool, obviously, to just discover the piece in a non-linear way. And after this first step of exploration of the sonogram, you can draw objects on this sonogram. So for instance, here we have a series of descending, so I just draw an object just upon it. And if I select this object, I just can play it. Sorry. According to three main modes, so this one is the most useful in my mind, which is the fact that what is under the shape in the sonogram is heard and whatever else is cut. You also have an option here, you cut a menu with 3 items as in audio cut. Actually, you can just apply no filtering, so you play the time region with the full spectrum. Or, as the opposite of what I just demonstrated, you can just cut the content of the shape. So here, everything else around the shape itself. So I'll just keep this shape sparse mode for now. And so I'll just draw a couple of other glissandi objects here. There are several drawing methods. For instance, here I can draw a different color rectangle here, for instance. I implement a polygon drawing mode will be available in the first release next month. So one interesting point of this implementation is that even though some shapes may obviously overlap in time, like these two first glissandi, you can hear them totally independently. Like, for instance, if I play the first one, sorry, if I just play that one, when you reach the point at which the second glissando starts, as it is not selected, you cannot hear it. And it's even more interactive than we thought. Okay, so when you are ready with your sound objects, obviously I can't do a whole series here, but if you perform a multiple selection, you can play these shapes according to two main modes. And the first mode, which is linear, you just play, sorry again, the whole sequence totally chronologically. I just okay, you can loop this selection, you can increase its speed. Most importantly, you can slow it down so that you can concentrate on a specific region more carefully. You can freeze the sound as well, and so on. In the second mode, which might be useful in many cases, you have a sequential playback option here, in which your selection will be played item after item. I'll just speed it up a bit to demonstrate this. So, first shape first, second shape then, and so on. Okay, obviously in some cases you may consider that you want to have coherent objects made of several spectral zones. So, for instance, let's just navigate like here, for instance, I've got a group of 3 treble attached sounds, so let's just draw a couple of objects on it. And if we want to consider that this is one single object, we can make it a group. So the group selection is here. And it is now just a single object, which I can just take as such.
That can also be particularly useful if you want to, say, have harmonics that are spread across the spectrum and group them as a single sonority. That's another use for that.
Yeah, absolutely. Right. So, I guess that's it for the interactive sonogram presentation. Obviously, you can, for your own analysis, just take the time of properly investigating the sonogram and make your own set of objects. At this point, I may just say that there's an undo-redo function that is very handy for obviously using the software in as much as possible standard way. Now, so far I've been drawing 2 general categories. So, with in mind the fact that I want to use this to draw analytical charts, I can put this object on an interface between the sonogram world and the chart maker world, which is a palette, which you can see on the right of the screen here. So before doing so, I just, so that it is clearer for this presentation, I just give a couple of shapes a name. Like here you can edit any object by giving it a name. So I just name it recently 1, recently 2, and I'll stop here. Recently 2, sorry. Okay. And when I'm done with this, I can just put these objects on my palette. So that I can later reuse this on the chart. If I want, of course, to be a bit more organized than that, if I have a very large set of objects, I want to be able to organize things within the palette according to categories. So I can create categories with names in the palette, like this and D. Another category like attacks here. And when I drop an object under some category, it will belong to that category. Okay. So, I don't have so much time, so I'll just, anyway, I'm quite ready about this sonogram side, so I'll move to the chart maker side of the program, which is in a separate window here. So, first of all, I can create a new chart which appears as this as a default one, then edit it as according to its general layout features. First of all, names.
Frédéric, just in case there's any ambiguity, you do have to the 1:45 on our schedule, don't feel constrained on time.
1:45,
yeah.
Right? So 15 minutes.
That's good.
Yeah. Okay. So I name this chart taxonomies. If I want to go to any other color for the margins or on the background, I have this option here. So obviously this very heavy yellow does not fit much, but this is a bit better, I think. More importantly, I mean the margins are obviously facultative, so you can just arrange a general layout as you want, but for analytical purposes, I think the most important feature in this general editor window is the possibility to create a default grid For instance, here I can just create 3-row, 2-column grid, so that I can arrange my objects within that general framework. And when I am happy with this first step of the chart maker, I can select my objects from the palette and drop them to the chart. Before doing so, I forgot to say that the palette objects are themselves interactive, which means that if I'm not sure of what is this green button here, I can see on the sonogram that it is the bass glissando. If I want to hear it, I can do so. And so now I'll select all of these items and drop them on the chart, palette items to chart, and then I'm free to arrange them where I want on my chart. So with Michael and Peter, the idea was to generalize the charts that you saw already for the wind chimes project. So in some way, we really wanted to keep things open as open as possible. Like for instance, here you have well, relatively small window. Of course, you can just make it a bit bigger like this. But of course, at some point when you have hundreds of objects, it might be useful to extend this window in some other way. So here you have a zoom possibility, which just enables you to see things a bit more clearly. But in this navigation set of features, you also have a possibility to extend the grid that you created, so that here it looks like I'm zooming, but actually I'm just extending the grid, which means that I can just put more objects in one cell, for instance. So after that, I can go back to my usual navigation, zoom out again, and so on. So here it is. And obviously, the chart objects are, if I go back to selecting object mode, are fully interactive and overall as well. So that's my first glissandi. The name is not so clear on the screen, but we can see the relationship that is between the chart maker and the Sologram. So here it is. There are a couple of features that we have put together for the first release, which are, for instance, I just zoom a bit maybe on some more specific regions so that it's more clear, but you can size objects as you want. You can also draw graphic lines, for instance, for representing trees between objects. So this line is actually purely graphic, which means that apart from being seen, it has absolutely no function, but you can, a bit like in a max patch, actually, you can just connect objects together like this. And this enables also to create playlists according to trees. I won't demonstrate it now because it's not ready yet, it's quite buggy actually, but the idea is that you can just make a whole tree and then play the tree item after item. And obviously one very important feature is to be able to make textual annotations on the chart itself. So if I now control click on it, I can make a new annotation with any text size, and just left this here and so on, so that little by little like this you can create a chart in a very open way. I mean, the way the chart appears in the end is really actually up to you. One last feature that I will demonstrate now is the fact that you can act on the grid that you created. if I just go to this edit grid mode and then I consider that here I've got these two cells on the right are just useless and that they could be merged. You can just merge them like this so that your chart now looks like that. And conversely, you can just split a zone into rows or two columns and so on, so that, for instance, here I'll split it into two columns like this, so that you can really arrange things in this very open way. So I guess that's it for the chart. Maybe I'll show briefly two charts that Michael and I elaborated before the AMS conference. So again, those of you who were in Lisbon just probably saw that, but just reboot now because I have to make just little calculation. But
by the way, just while that's happening, to say this is, as we've said, written in Max. You can see at the moment we're actually running Max, but what we release will be compiled, so that people won't need to own Max at all. It will just run as a standalone, so it'll just be an application in its own right. You won't need to purchase Max or anything. It will run on its own, and you'll still be able to manipulate all the data and everything.
yeah, and you can, I mean, as in many software, you can organize your sessions according to a system of folders in the Finder, but within one given analysis, you can save, for instance, a given state of your sonogram, as you save presets in standard software, so that you can switch to state 1 to state 2 to state 3 very easily. So here we are in still in the Planck-Délier piece, but with a bit more shapes, so which are set according to this attack sounds and glissandi sounds again. And one important thing that I forgot to tell is that you can have as many charts as you want in your chart maker. In this case, we have two of them, taxonomy and paradigmatic chart. And when you want to play a selection of objects, for instance, this pitched glissandi, noise attacks, pitched attacks that I selected, which appear in black and white here. In that case, the time axis is actually from top to bottom of the screen. So I just here ask for playing them vertically. Sorry, I have to actually be on the chart window to play this way. Yeah, correct. So I don't know if it's maybe not too visible here, but you can see that on the chart, the currently played object is framed in blue, while the other ones are framed in black. But with a clear view of the program, you can very clearly see the correlation, the direct correspondence between chart objects and sonogram objects. So here we are for this selection. Should I leave a bit of time for questions now? Or?
Finish your point, I think, Frédéric. We've not seen this before.
Okay, that's great. So maybe I can demonstrate this undo function that I was just talking about before. Like for instance, if I do any kind of things like that, but that I'm not happy with, I've got an undo button which is just running pretty well anyway, so that, I mean, this is not a very common in Max-based software, but in that case it works rather well. You've got undo history, redo history, which is very useful for the analysts to use. If I now save this as a preset, I just save it here, and if I just want to design things differently, I'm doing things a bit randomly here, but it's just for the purpose of this demonstration, and say this as preset 2. So say this. Okay, now if I want to go back to the previous state, it will work. I'm not so sure. Oops, yeah. Just a minor break here, but if I go back to the power image chart, I'm back to my previous chart. So yeah.
So as an analyst, you could save various different views that you wanted people to see and move between them very quickly.
Can I ask a question? So can you save a history of what you're doing, so you can go back to something you did 7 days ago, when you realise you've been going down a bad route for the last week?
Yeah.
You can go back 7 days and say, oh, I'll go back there.
Yeah, absolutely.
Okay.
I mean, the good point of this design is that, I mean, it was not intended on the origin, but the way we designed it is enable the fact that you can quit Max, and when you reboot the program, when you reboot TIAALS, you can undo what you did last time, which is great. Yeah. So I think I took about roughly.
We move to questions. Any comments? Questions? Frédéric, Morgan.
I was wondering about the chart. Now you put the chart together by hand, so you basically defined all the different categories. You searched for the Glisandi by hand in your score, in your spectrum, basically. Is there a function which actually allows you to do that automatically? That you say you define, you are searching for ABC, and then this will basically put this together?
Well, not in the current release. I mean, our point, our design has always been to favor manual actions rather than anything automated. But as part of the future developments that we wish to implement, we will, to some degree, enable some whichever parameter could be interesting to sort data according to centroids or to pitch or to frequency range or whichever you can imagine. It's on the to-do list, but not for this first release. For now, it's quite manual anyway. But obviously, having an automated-based aid to this set of operation would definitely be useful. Yeah.
Just to amplify on that a bit, I think our basic starting point, similar again I think to something Simon said, has been that we're providing tools for the human analyst, and we see analysis as being about human listening, and therefore we put the priority on what we hear as analysts and what our users hear as analysts, and making our decisions on those bases. But we are interested in exploring various options that might help that process, but in the end I think we're not interested in, well, I'm not saying we wouldn't be interested in, but our first interest isn't in scientifically calculated data, it's in what we perceive as humans.
It would be interesting though to say to define an area manually, so one that's Glisandi, and then be able to say to the program, can you find me any more of these? You can always say, well, you know, I don't agree with this. It would be very helpful to do that.
Any other thoughts? Craig.
I'm presuming with the chart functions, it's possible to deconstruct the piece and orient it back together as an experimental composition design.
Well, that's something that we hear from time to time, which is obviously it would be great to, I mean, it would be great for us to see people use this, which I mean, initially is definitely a tool for music analysis, but if some people use it for creative purposes, I mean, we'd be more than happy, obviously.
When I showed a much more primitive version of this to when I showed a much more primitive version of this to Dennis Smalley as part of the wind chimes analysis, see what he thought of what I was doing, one of his first reactions was actually, I'd like to compose with this. So yes, that might be an option as well.
The other thing that springs to mind is the Hans Keller structural analysis thing, where you could actually present like a condensed form of the piece, which displayed its key structural features. That's the best analytical method I've ever come across. And that was for traditional music.
Yes, I'm aware of that. I did quote it in my music analysis article, but in the reviewing process it got cut out. So I don't know, they didn't think it was relevant somehow. So I did have it in there originally, but I'm very much aware of that. And I'm going to give another example from the Dennis Smalley one. And he doesn't agree with this, but he was happy for me to propose it as an idea. There was one passage that I thought was a sort of, I can't think of the word that I want, but like an insert within between two other passages that I felt linked together perfectly, and this was like a sort of an elaboration on it. And so I gave people the option of playing through that section of the piece, omitting the elaboration, and then seeing other. And he doesn't agree with that analytical interpretation, but he's happy for me to present it anyway.
Well, thank you very much indeed for that presentation. We look forward to its launch and future development. Thank you.